Adding an equipment ground and replacing 2-wire receptacles with 3-wire receptacles offers several benefits. Firstly, increased safety is a major advantage. Grounding provides a safe path for electrical current to flow in the event of a fault, preventing serious shocks or electrical fires. Secondly, grounding reduces the risk of electrical noise. Grounding helps to dissipate unwanted electrical noise that can interfere with electronic devices. Thirdly, grounding improves appliance performance. Some appliances, such as computers and refrigerators, require proper grounding to function optimally. Finally, compliance with modern building codes is another benefit. Most building codes now require electrical systems to be properly grounded for safety reasons. Replacing 2-wire receptacles, those without a ground wire, with 3-wire receptacles, those with a ground wire, is essential to complete the grounding circuit. This ensures that all electrical devices connected to the receptacle have a proper grounding path. The steps to add grounding are as follows. 1. Identify the grounding source. Locate the main electrical panel and identify the ground bar or grounding electrode. 2. Run ground wires. Install grounding wires, typically green or bare, from the grounding source to the electrical boxes where the receptacles will be replaced. 3. Connect ground wires. Connect the grounding wires to the green screw terminal on the 3-wire receptacles. 4. Test the grounding. Use a multimeter to verify that the receptacles are properly grounded. Several considerations exist. Firstly, cost is a factor. Adding grounding can be a significant expense, especially in older homes. Secondly, accessibility should be considered. Ensure that attic and crawl space access is available for running grounding wires. It is recommended to have a qualified electrician perform the work to ensure proper installation and safety. Grounding is a critical safety measure that protects people and property from electrical hazards. Grounding provides a low impedance path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit. Without grounding, a fault current could flow through a person or object, causing serious injury or damage. Replacing 2-wire receptacles with 3-wire receptacles is an important step in improving the safety of an electrical system. 2-wire receptacles do not have a grounding connection, so any appliance or device plugged into them is not grounded. This means that if there is a fault in the appliance or device, the fault current could flow through the person using it. 3-wire receptacles have a grounding connection, so any appliance or device plugged into them is grounded. This means that if there is a fault in the appliance or device, the fault current will flow through the grounding wire back to the source, causing the circuit breaker to trip and de-energize the circuit. This protects the person using the appliance or device from electrical shock. Grounding also helps to reduce electrical noise. Electrical noise can interfere with the operation of electronic devices, causing them to malfunction or produce inaccurate results. Grounding provides a path for electrical noise to dissipate, reducing its impact on electronic devices. Proper grounding is essential for the optimal performance of some appliances. For example, computers and refrigerators require proper grounding to function correctly. Grounding helps to ensure that these appliances receive a stable and reliable power supply, which is necessary for their proper operation. Most modern building codes require electrical systems to be properly grounded for safety reasons. This means that any new construction or renovation work must include grounding. Grounding is an important safety measure that protects people and property from electrical hazards. If your home has 2-wire receptacles, it is recommended that you have them replaced with 3-wire receptacles to improve the safety of your electrical system. The first step in adding grounding is to identify the grounding source. The grounding source is typically the main electrical panel. The main electrical panel is the point where the electrical service enters the home. The main electrical panel contains a ground bar or grounding electrode. The ground bar is a metal bar that is connected to the grounding electrode. The grounding electrode is a metal rod that is driven into the ground. The grounding electrode provides a path for fault current to flow back to the source. The next step is to run ground wires. Ground wires are typically green or bare copper wires. Ground wires are run from the grounding source to the electrical boxes where the receptacles will be replaced. The ground wires should be sized according to the National Electrical Code or NEC Table 250.122. The ground wires should be installed in a way that protects them from damage. The next step is to connect the ground wires. The ground wires should be connected to the green screw terminal on the 3-wire receptacles. The green screw terminal is the grounding terminal. The ground wires should be connected securely to the green screw terminal. The final step is to test the grounding. The grounding should be tested using a multimeter. A multimeter is a test instrument that can measure voltage, current, and resistance. To test the grounding, set the multimeter to measure resistance. Connect one probe of the multimeter to the green screw terminal on the 3-wire receptacle. Connect the other probe of the multimeter to the ground bar in the main electrical panel. The resistance reading should be less than 5 ohms. If the resistance reading is greater than 5 ohms, there is a problem with the grounding. Several factors should be considered when adding grounding. Firstly, the cost should be considered. Adding grounding can be a significant expense, especially in older homes. The cost of adding grounding will depend on the size of the home, the number of receptacles that need to be replaced, and the complexity of the wiring. Secondly, accessibility should be considered. Ensure that attic and crawl space access is available for running grounding wires. The attic and crawl space may need to be cleared of obstructions to allow for the installation of ground wires. Finally, professional installation should be considered. It is recommended to have a qualified electrician perform the work to ensure proper installation and safety. A qualified electrician will have the knowledge and experience to properly install grounding and ensure that it meets all applicable codes and standards. Grounding is an essential safety measure that protects people and property from electrical hazards. By adding grounding to your home, you can improve the safety of your electrical system and protect yourself and your family from electrical shock. Replacing 2-wire receptacles with 3-wire receptacles is an important step in improving the safety of an electrical system. By replacing 2-wire receptacles with 3-wire receptacles, you can ensure that all appliances and devices plugged into them are grounded. This will protect you from electrical shock in the event of a fault. Grounding helps to reduce electrical noise. Electrical noise can interfere with the operation of electronic devices, causing them to malfunction or produce inaccurate results. By grounding your electrical system, you can reduce the amount of electrical noise and improve the performance of electronic devices. Proper grounding is essential for the optimal performance of some appliances. By grounding your electrical system, you can ensure that these appliances receive a stable and reliable power supply, which is necessary for their proper operation. Most modern building codes require electrical systems to be properly grounded for safety reasons. If you are planning any new construction or renovation work, make sure that your electrical system is properly grounded. Grounding is an important safety measure that protects people and property from electrical hazards. If you have any questions about grounding, consult with a qualified electrician. A qualified electrician can help you determine the best way to ground your electrical system and ensure that it meets all applicable codes and standards. The NEC provides detailed requirements for grounding and bonding electrical systems. It is important to follow these requirements to ensure the safety and proper operation of your electrical system. Article 250 covers the general requirements for grounding and bonding. Article 250.4 specifies the general requirements for grounding and bonding electrical systems. This section requires that electrical systems be grounded in a manner that is permanent and effective. Article 250.24 covers the grounding of service-supplied alternating current systems. This section requires that the neutral conductor of a service-supplied alternating current system be grounded. Article 250.30 covers the grounding of separately derived alternating current systems. This section requires that the neutral conductor of a separately derived alternating current system be grounded. Article 250.50 covers the grounding electrode system. This section specifies the requirements for the grounding electrode system. The grounding electrode system must consist of one or more grounding electrodes. The grounding electrodes must be connected to the grounding conductor. Article 250.52 covers the types of grounding electrodes. This section specifies the types of grounding electrodes that are permitted. The grounding electrodes must be made of copper, aluminum, or steel. The grounding electrodes must be at least 8 feet in length. Article 250.64 covers the grounding electrode conductor. This section specifies the requirements for the grounding electrode conductor. The grounding electrode conductor must be made of copper or aluminum. The grounding electrode conductor must be sized according to the NEC Table 250.66. Article 250.92 covers the bonding of metal enclosures. This section requires that all metal enclosures be bonded together. Bonding is the process of connecting metal enclosures together to create a low impedance path for fault current. Article 250.96 covers the bonding of metal water piping systems. This section requires that metal water piping systems be bonded to the grounding electrode system. Article 250.104 covers the bonding of other metal piping systems and exposed structural metal. This section requires that other metal piping systems and exposed structural metal be bonded to the grounding electrode system. Article 314.4 covers the grounding of outlet boxes. This section requires that outlet boxes be grounded. Outlet boxes must be grounded by connecting them to the grounding conductor. Article 406.4 covers the grounding of receptacles. This section requires that receptacles be grounded. Receptacles must be grounded by connecting them to the grounding conductor. Grounding is an important safety measure that protects people and property from electrical hazards. By following the requirements of the NEC, you can ensure that your electrical system is properly grounded. Adding an equipment ground to a home and replacing 2-wire receptacles with 3-wire receptacles is generally a good practice for several reasons. Although ground fault circuit interrupters or GFCIs provide a significant level of protection against electric shock, they don't address all the issues that grounding does. GFCIs protect against ground faults, which occur when current leaks from a circuit to ground. While GFCIs are very effective at preventing electric shock in these situations, they don't protect against other types of electrical faults, such as short circuits or overloads. Grounding provides a path for fault current to flow back to the source, which can help to trip a circuit breaker or fuse and prevent damage to equipment or wiring. Grounding helps to reduce electrical noise and interference, which can improve the performance of electronic devices. Grounding can also help to prevent static electricity buildup, which can be a nuisance and can even damage sensitive electronic components. Older 2-wire electrical systems may not meet modern safety standards. Adding grounding can bring the electrical system up to code and improve its overall safety. The presence of GFCIs does not eliminate the need for grounding. GFCIs are designed to protect people from electric shock, while grounding is designed to protect equipment and wiring from damage. It is recommended to have a qualified electrician inspect the electrical system and determine the best way to add grounding and replace 2-wire receptacles with 3-wire receptacles. The electrician can assess the existing wiring, identify any potential hazards, and ensure that the work is done safely and in accordance with all applicable codes and standards. Adding grounding to an older home and replacing 2-wire receptacles with 3-wire receptacles can provide several benefits, including increased safety, reduced electrical noise, and compliance with modern building codes. While GFCIs provide a significant level of protection against electric shock, they don't address all the issues that grounding does. Therefore, it is generally recommended to add grounding to an older home, even if GFCIs are already present.